This is problem number 4 on the sample test problems for test number 2. Find all real solutions to each of the following equations and inequalities. A, square root of 2x minus 3 plus x equals 3. So the technique when you see a square root is to get rid of it by squaring both sides. But squaring while there's still this plus x in the way is a bad idea. So we want to get that square root by itself first. And so we'll subtract x from both sides. Square root of 2x minus 3 equals 3 minus x. Now we'll square both sides. The nice thing on the left is that the square root of 2x minus 3 squared is just 2x minus 3. Equals. Really easy to make a mistake on the right-hand side, to put something like 9 plus x squared or 9 minus x squared. Please don't do that. If you see 3 minus x squared, write it twice. And as soon as you've written it twice, maybe you start to think of that famous acronym FOIL. And so if we FOIL here, we get 9 minus 3x minus another 3x plus x squared. And so it should be 9 minus 6x plus x squared. And so it's really easy to miss the outer inner terms if you just look at it and don't write it twice. So let's fix that. And now that we've succeeded in getting rid of the radical, this is an ordinary looking quadratic equation. Generally, you want one side to equal 0. So let's move everybody to the right. 0 equals, I'll write my x squared first. I had negative 6x, I'm subtracting another 2x, so I get negative 8x. Had 9, I'm adding 3, so we get plus 12. Certainly the quadratic formula works, but if the thing factors, it is quicker to factor it than to use the quadratic formula. So let's factor. First things will be x and x. We're going to need 2 minus signs. Product is 12 and the sum is 8, so that sounds like 6 and 2. And once it's factored, you split it down the middle and write two new simpler equations. Either x minus 6 is 0 or x minus 2 is 0. So we get x equals 6, x equals 2. One downside of dealing with square root equations, with radical equations, is that you could do everything right, but still end up with answers that don't really work. So it is mandatory to check both of these. So let's go ahead and start by plugging in x equals 2. Let's do x equals 2 first. So we're replacing this x with a 2 and this x with a 2. So the question is, does the square root of 2 times 2 minus 3 plus 2 equal 3? That's the question. Just replacing the x's with 2's. So this is really the square root of 4 minus 3, which is 1, plus 2 equals with the question mark 3. Square root of 1 is 1, plus 2, does it equal 3? Yes, it does. So x equals 2 works. That's a solution. Let's check the other one. X equals 6. Again, going back to the original, where those purple arrows are, and replace those x's with 6's. Okay, so that top left equation, we make those x's equal to 6. Square root of 2 times 6 minus 3 plus 6 equals with the question mark 3. Okay, let's see if this works. Square root of, let's see, that's 2 times 6 is 12, minus 3 is 9. So the square root of 9 plus 6 equals 3. The square root of 9 is 3, plus 6 equals 3. 9 equals 3, and clearly it does not. So what that means is that x equals 6 gets rejected. And that x equals 6 didn't come from just some random place. If you are willing to take the square root of 9 as being not just 3, but maybe negative 3, then all of a sudden we have an equation that's true. Negative 3 plus 6, oh yeah, that does equal 3. But the square root of 9, this symbol right here denotes the positive square root of 9. And the equation simply is not true with the positive square root of 9. Okay, let's take a look at part B. Absolute value 2x plus 1 equals 17. If you see absolute value, you need to trade that in for two brand new equations. In both equations, basically you copy down the equation as it is without any absolute value. But here's the trade. Instead of absolute value, your two equations, one of them is the original, that'll be the one on the left, and the one on the right, it's almost the same as the original, but instead of 17, you make it negative 17. So two equations, one of them is copied with the positive 17, the other one becomes negative 17. And then hopefully it's a simple matter of solving for x. So we'll subtract 1 and divide by 2, and subtract 1 and divide by 2. And it's really easy to think, okay, plus or minus somehow has this, absolute value somehow has this plus or minus associated with it. So if you just solve the one equation going down here and get x equals 8, then the other answer should be negative 8. And you can see it's not. Oftentimes we lose that plus or minus symmetry when you go through the details. So you actually have to go through the details on both sides for both equations. Part C, negative 4 is less than 2 minus 3x, which is less than or equal to 11. Okay, the goal is to solve for x. We'll first subtract 2. Usually you say from both sides, but now we have 3 sides per se. So subtract 2 from everybody, we get negative 6, less than negative 3x, less than or equal to 9. Then divide everything by negative 3. And here we get 2, less than x, less than or equal to negative 3. And I'm hoping that you recognize there's a problem here. So first of all, if this were true, then it would imply that 2 is somehow less than or equal to negative 3, which it's not. And so the error that we made, or the error that I made, is that when I divided by negative, I'm actually obligated to change the direction of those inequalities. And I didn't do it, I just copied them. So these ones should both be reversed, and then we'll have our answer. 2 is greater than x, which is greater than or equal to negative 3.